In this demo, we will integrate blob storage, event grid, and a logic app to process an image once it's been updated on blob storage, one of the examples previously described. As you remember, in the section on working with logic apps, we moved the processing of changed images from an app service endpoint that picked up messages from the storage queue to a logic app with a blob storage trigger. What we're going to do now is put event grid in between to improve the reliability thanks to replay and net lettering functionalities, and to avoid excessive polling of blob storage. We need an event subscription for that. We can do that via the event subscription blade, but another easy way to do that is via the overview blade by clicking on top here to add an event subscription. If you prefer to do that via the CLI, what you're looking for is the AZ event grid event subscription command. Alright, let's give our subscription a name. AppDev EVGS. That's the acronym for event grid subscription. Dev WE image blob change processor. Then we need to choose the event schema. This is essentially the format of the event messages that are being sent. Event grid schema is Microsoft's proprietary format, while the cloud event schema is an open specification used to describe event data. More info on that can be found via the link on screen. You can also find a bit of information about it in Microsoft's documentation. I tend to prefer to use standards, so I'm going to go for the cloud events schema type. The topic details we want are pre-filled because we are adding an event subscription to this system topic. And then we can already filter a bit. Typically, you don't want all events from a source to be sent to an event handler. In our case, we only want to send an event when an image blob is updated or created. The blob created event is the one that fires in both cases, so also when one is updated, not just when it's created from scratch. That also means we do not need the blob deleted event type here. Then we need to select the endpoint type, so the event handler that will handle our event. Small issue, we don't see logic app here. So how do we do this then? Well, that is where the webhook comes into play. We can use an HTTP request trigger for our logic app, which gives us a URI we can use as a webhook endpoint. The event will thus be pushed to that URI, which will trigger the logic app. But we don't have that endpoint yet, so I'm going to open the logic app because we need to configure it here. So let's open the logic app. That's our process destination image changes logic app. Let's look at the designer. And seeing our use case is to get rid of this blob storage trigger, we can simply change this here. So let me delete this trigger. Let's add an HTTP trigger. So when an HTTP request is received, we want to execute something. We want to handle the event. That means we are going to need to input a few other things here, but for now all we need is the URI. And the URI is generated after save, so let me just save this here and then copy the URI. Now let's go back to our event subscription, click configure endpoint here and paste in the endpoint of our HTTP request trigger. There we go. Let's move to filters on top here. Here we can additionally filter out events before they are pushed to the destination. For example, with a subject filter, we could choose to only pass JPEG-related events from a specific container. Doing so avoids an overload of events you don't need, so let's enable such a filter. I'm going to state that the subject needs to begin with the location of our destination images container. So, / blob services, default containers, destination image. And let's check if that is indeed correct. So I can easily verify this by going to my storage account, containers, destination images here. So it is indeed named destination images. All right. Destination images, that's looking good. And ends with .jpeg. Why not? With advanced filters, you can filter on almost anything, depending on the event schema that was selected. In our case, that's the cloud event schema. If we have a look at that, we see that we could filter on type, time, subject, source, and so on. I'm not going to add another filter, I simply want all images to be processed. On the additional features tab, we can configure that lettering and retry policies. We will do that, but later on in this section. For now, I'm going to leave this as is. And then there's delivery properties. We can customize the actual request that is sent to the destination by adding headers with static values or dynamic values, calculated from the request body. That's already pretty advanced. I'm going to go with the defaults. And this, by the way, depends on the type of subscription you're making, as do filters and additional features you can configure for that matter. So if you're not subscribing to something related to blob storage, this will look different. Let's click Create. And our subscription was successfully deployed. You can find the subscription below here or via the Event Subscriptions tab. All right, let's test this. To test this, what we want to do is send something that triggers an image blob update or creation. We have that, of course. Sending a put request to the images endpoint will trigger that. Let's check the host address route first. That image update endpoint has been deployed to our app service, so this is the host address route I need. And let me send the request. And that is forbidden. That indeed makes sense. If you remember in the previous section, we ensured that only requests from APIM to our app service were allowed. We did that by adding an IP filter. The problem with that, of course, is that I can no longer send these requests from this HTTP file from my local machine. The second problem is that, well, we didn't create an endpoint at level of APIM yet for updating the images. So we could now go and create such an endpoint or rather an API definition in APIM for this. But to make our lives a little bit easier, I'm simply going to disable the IP restriction for now, just to be able to continue with this demo. So let's open the app service. And let's navigate to the networking tab. Let's open the public network access restrictions we have here. And I'm simply going to enable access from all locations again. That's the easiest way to ensure that the demos in this section work again. All right, let's continue. As you know by now, things like this may sometimes take a little while to propagate over Azure. So if this doesn't immediately have an effect, just give it a few minutes. Let's send the request again. Let's have a look at the overview blade. And here we indeed see that something seems to have happened. We see that a bunch of events have been published. 10, in fact, while only 2 have been delivered. So only 2 resulted in a match. And that makes sense because we have a trigger in place. And that trigger ensured that only 1 event per image change has been sent to the event handlers, in our case the Logic app. So as you can see, that subject filter was definitely necessary. This should have triggered our Logic app, so let's go and have a look at that. Let's have a look at the runs history. And indeed, the Logic app was triggered, but it seems to have failed. Let's open one so we can have a look at the details. Apparently, sending the email has failed. Let's have a look. If we have a look at the HTTP request trigger, we find the full incoming request in Cloud Event Schema format in the request body. As you can see, that is an image update for an image of Antwerp. What I think is sometimes a bit more easy to figure out what exactly is going on is to have a look at the raw outputs. This gives us a bigger view with better coloring, so I kind of like this one better. And as we can see, the content type is indeed that cloud event, so this confirms to the Cloud Event Schema. And the body contains a bunch of interesting data related to the event. This is what we can use when processing it. But apparently, processing goes wrong. Sending an email resulted in an invalid template error. That makes sense, of course. We are still pointing to incoming data from a blob-created storage event, but that's not what we're getting anymore. What we're getting now is an Azure Event Grid event that follows the Cloud Event Schema definition. So let's fix this. Let's open the Logic App Designer. Let's open the action that fails. Send an email. So this here is what's causing the issue. If we have a look at the function in here, we'll see that we're looking for a name property on the body, and that isn't there anymore. Yet we do know the incoming schema. The thing is though, this is quite inconvenient to start editing because the action doesn't know what's coming in. It doesn't know yet about the schema of the data. Yet we do. We know that it confirms to the Cloud Event Schema. Let's see if we can improve on this experience. Let's open the trigger again here. We can input a request body JSON schema down here. If we do that, we'll get some form of IntelliSense in the action underneath the trigger that makes it easier to select the correct fields. But where do we find that schema then? Well, we could go to the Cloud Event specification and manually create it from that, but there is an easier way. We have a payload from our failed Logic App run. So we can use that to generate the schema from. Underneath the request body input box here, there's a link. Use sample payload to generate schema. I'm going to open a failed run. I am going to select the body. Let me just copy that actually. All right. And then let's go back to the Logic App Designer. Let's open our trigger again. Let's choose to use a sample payload to generate a schema from. Paste in the sample payload, click done, and there we go. Here is our schema. Let's go back to send an email. And now the designer knows what's incoming, so it should help us with selecting the fields. So if I go to dynamic content, I can, for example, select the subject. So now I'm stating that if the subject contains Antwerp, we're going to output great travel destination and otherwise okay travel destination. Let's click update here. That should have fixed that. All right. While I'm here, one more thing that I'm going to do is ensure that our HTTP request trigger is only triggered for post requests, as it's a post request that is used by EventGrid when the message is effectively sent. So I'm only going to allow post here. All right, let's save this. And now let's test this. As we know, we can simply select a failed run and resubmit it to test. So let's do that. All right, that was successfully resubmitted. Let's refresh the runs history here. And there we go. We now have a succeeded Logic App run. Our integration works. So that is how you integrate via the portal between Azure resources. Now let's have a look at how to integrate from custom code.